Okay, come to next application, potential step. So in our first application, we have discussed about the infinity potential well particle in one-dimensional box. Second application is the potential step. So in the last month note, I have given problems on potential step. So you have to write the problems in your assignment copy of potential step. Just I will give some clue about the potential step. In potential step, what happens? The potential condition is here potential is 0, means when x less than 0, so it is the x axis, okay, and it is your vx. So along when x less than 0, potential is 0. When x greater than 0, potential is v naught. Okay, this is the potential condition. Here the energy discussion is energy of the particle is greater than the barrier, that is step height. So that is v naught. So when energy greater than v naught, so what is the possibility? Possibility is particle will go to the second region. So it is a first region, it is a second region. So the particle will enter to the second region without any reflection. But quantum mechanically, if energy of the particle greater than v naught, there may not be 100% transmission. There is a possibility of reflection also. So in that application, you have to find out the reflection coefficient and transmission coefficient. And if you add the reflection coefficient and transmission coefficient, r plus t is equal to 1. So this relation always r plus t is 1. R plus t, reflection coefficient, transmission coefficient is equal to 1. Okay, so you copy the problems what I have given in the last month note. You just copy the problems of the potential step. You have to find out the reflection coefficient and transmission coefficient. You can check 2-3 problems I solved in my note. So you just copy that problems in your assignment copy. The important is your tunneling. The third application, that is a potential barrier, where we have to discuss about the tunneling. So in tunneling, what is tunneling? Tunneling means what? It is your potential barrier when the particle energy E is less than v naught. If energy of some of the particle is moving from region, there are 3 regions here. Here there are 3 regions. So when the particle is incident from region 1 to region 2, classical mechanics says that the particle cannot go to region 3. Classical mechanics says. But quantum mechanically, there is a finite probability that the particle can enter through region 2 and reach to region 3 even if the energy is less than v naught. Even if the energy of the particle less than the barrier height, there is a non-zero probability that the particle can go to region 3 through tunneling. So this is called tunneling. So what is tunneling? If the energy of the particle means E is less than the barrier height means v naught, then particle has a finite non-zero probability of penetrating through the barrier. So even if the energy is less than v naught, energy of the particle less than the barrier height, the particle can reach to region 3 by tunneling. So this is the tunneling. So based upon this tunneling, let us discuss one problem. A 50 electron volt electron approaches a potential barrier 70 eV high. So 70 eV is your V naught. It is your V naught. V naught is 70 eV and 50 eV is your energy of the particle. So energy of the particle is 50 eV and the barrier height is 70 eV. What is the probability that the electron will tunnel through the barrier for barrier thickness? There are two bits are there. Barrier thickness A is equal to 1 nanometer, another 0.1 nanometer. That means 1 nanometer is 10 times less, 0.1. So you have to find out the transmission probability in both cases. What the value of?
Sir.
So we have to find out the transmission probability at A is equal to 1 nanometer, A is equal to 0.1 nanometer. So 0.1 nanometer is 10 times less than 1 nanometer. So we have to find out T value in both cases and then compare. Okay, first the formula for transmission probability T. Formula is, it is a important formula. T is equal to approximately e to the minus 2a alpha. Minus 2a alpha. What alpha? You can check the note. What is alpha? Alpha you will get from this formula, root over 2m by h square V naught minus E. From this formula you find alpha. So what is V naught? V naught is the barrier height, 70 eV. What is E? E is the energy of the electron, incident electron. What is M? M is the mass of the electron. H cross is h by 2 pi. H by 2 pi whole square. H is Planck's constant. So from this formula you find alpha and then you check the formula. Formula is A has A here, two cases are there. So alpha you will get alpha for common for both bit alpha. It is a common for two cases. So first find out alpha value. Alpha value. M is the mass of the electron. H cross V naught is the barrier height 70 eV. It is 50 eV. So from this calculation you find alpha value, and then you first consider the first case. A is equal to 1 nanometer. 1 nanometer is 10 to minus 9 meter. So 2a alpha, as per the formula you have to find out 2a alpha. 2a alpha is here 46. If you calculate 2a alpha is 46. So from then you put in the formula. T is equal to e to the minus 2a alpha. So 2a alpha is your 46. So 46 value. So when you find the exponential of minus 46, the value is 1.3 into 10 to the minus 20. This is the value 1.3 into 10 to the minus 20. That means the electron, what is the conclusion of this? Conclusion is the electron has only here the electron has only one chance, because here 1.3 let it is 1. 1.3 means let it is 1 chance in 10 to the power 20 tunnel through the barrier. So it is the transmission probability. 1 chance in 10 to the power 20 tunnel. So it is the first case. Then come to second case. Second case when you put just A is equal to 0.1 nanometer. So only this value change. When this value change, 2a alpha will be 4.6. So 4.6 because it is 46. So when you take 0.1 nanometer, so it will be 4.6. So by applying the formula, you will get transmission probability is equal to 0.01. So 0.01 means what? Generally it is 1%. 1%. So what is the conclusion of this result? Conclusion is the electron has a 1% chance of penetrating a 0.1 nanometer thick barrier. Thus, by reducing, if you compare this both, you will see it is 0.01, it is first case it is 1.3 10 to the minus 20, that means 0.013 10 to the minus 18. So 0.013 in 10 to the minus 18, it is 0.01. So if you compare these two value, first case and it is second case, this is the result. By reducing the barrier width by a factor of 10, probability increased by 10 to 18 times. You can see it 10 to minus 18. So minus 18 means what? It increases 10 to 18 times. So if you compare these two results, if you compare to this result, this is the conclusion. First case, second case. So it is the probability increased by 10 to 18 times. So it is the solution of the first problem. Now one assignment to you based upon this problem. One assignment. The same problem, just you have to change the values. You have to take the energy of the particle E is equal to 30 electron volt. Barrier height is 40 electron volt. And two case again you have to discuss two case. Barrier width 1 nanometer, barrier width 0.1 nanometer, and see the difference of transmission probability. So in both case you have to find out the transmission probability and compare. Again I am repeating the question. Energy of the particle is 30 electron volt, barrier height is 40 electron volt, barrier width is 1 nanometer first case, second case barrier width is 0.1 nanometer. You have to find both case transmission probability and then compare what is the result. This is your assignment. So similarly you collect problems for other applications, means potential step, potential barrier, infinite potential well. So from different books you collect some problems. Thank you.